Now coming to the topic nanotechnology. Nanotechnology. Nano means 10 power minus 9. Nanometer means 10 power minus 9 meters. And this nanotechnology has derived from the Latin word dwarf, which means as small as nanoparticle. Okay, and this nanotechnology are having groundbreaking solutions in future. And this nanotechnology word was introduced by, and this nanotechnology was firstly recommended by Dr. Richard Feynman in 1959, and but it was not that much popularized at that time. Later on, Eric Drexler made the nanotechnology very much popular. Actually, what nanotechnology is? Nanotechnology means it is the study of the particles that ranges from 1 nanometer to 100 nanometers. The range of the nanoscale will be 1 nanometer to 100 nanometers, and 1 nanometer is 1 millionth of a millimeter. And what is this nanoparticle? What is the size of this nanoparticle actually is? And this molecule is lesser than nanoparticle. See, we know that the atom contains the nucleus, right? The atoms combined together will form molecules. Then after that molecular level, this nanoparticles will occur. Means nucleus is much smaller than atom, and atom is much smaller than the molecule, and that molecule is much smaller than nanoparticle. Okay, as nanoparticle or nanoscale deals with smaller size particles, actually the usual law of physics that doesn't apply to this nanoparticle, because nanoparticles deals with very small size particles. To deal with such a small size particles, we are using quantum mechanics in this nanoparticles. And when the nanoparticles are in bulk in size, they act as insulators, and when they are reduced to nanoscale, they will act as semiconductors. And when a substance is changed from large size to nano size, it may turn into opaque to transparent. And what is this nanotechnology actually means? We can change the substances at the molecular level. Actually, we can make changes to the substance at molecular level by using this nanotechnology. Okay, when we make changes at the molecular level, we can change the entire substance. We can change the properties of entire substance actually. And melting point can also increases when this nanoparticle is smaller in size, and when it is in the bulk form, its surface area expands. Due to this surface area increases, the melting point can also increases. Okay, and coming to this history of nanotechnology, as we know that in 1959 Dr. Richard Feynman has recommended this nanotechnology, and later on Eric Drexler has popularized the term nanotechnology. But in the year 1974, this nanotechnology was actually introduced by the term actually derived by Norio Taniguchi. Okay, and later on 1981, we have access to nanoparticles, we have access to nanoscale. We have made work on this when only the invention of scanning tunneling microscope is done. Okay, and I'll let us discuss about the scanning tunneling microscope, what it actually is. And see, what is the scanning tunneling microscope actually is. And this scanning tunneling microscope works majorly on three principles. One is quantum mechanical effect, and another is piezoelectric effect, and another one is feedback loop. By this STM, scanning tunneling microscope, we can actually get access to the nanoscale range. What is a nanoscale range? It is a 1 nanometer to 100 nanometers, right? By normal, if you look, we cannot access to that. By using the scanning tunneling microscope, we can actually get access to this range. And coming to this scanning tunneling microscope, the working, generally we see an electron can exist either in particle nature or either in wave nature. Electrons exist at wave nature at the smaller scales, that is at nanoscales, electron exists as waves. And when an electron, that is in the wave form, travels like this, and if you are having a thin wall like this, when this wave hits this thin wall, the wave actually doesn't die at once. It starts reducing its amplitude, and it accumulate into this wall by reducing its amplitude, and it moves like this. And if you are having a very broad wall like this, when this electron, which is a wave, is traveling, at the first hindrance it doesn't die. It travels slowly like this by reducing its amplitude. This effect is known as tunneling. By using this tunneling effect, we are having this scanning tunneling microscope. In this scanning tunneling microscope, suppose this is a surface and we are having this tip. This is known as tip. This tip actually points to the surface. It magnifies the surface and it observes the particles, observes the molecules that are at the nanoscale. By using this scanning tunneling microscope, we can get access to the nanoscale range. And after this, we have the development of fullerences in 1985. Fullerences are actually closed or cylindrical carbon atoms. Okay, if they are closed, it means usually they are buckyballs C60, and the C60 buckyballs having vacuum in that. And if they are cylindrical in shape, means they are actually carbon nanotubes, and this carbon nanotubes behaves like superconductors to semiconductors. And coming to this, after this invention of 1985 fullerences, we have they got 1995 they have got Nobel Prize for this fullerences invention. And coming to this advantages of carbon nanotubes, they are having high thermal and electrical conductivity, they are having optical properties, flexibility, increased stiffness, high tensile strength, lightweight, and ability to manipulate. They can manipulate easily, but their earth remains strong, and they are having thermal and electrical properties of products. And what are the applications of this nano particles actually? They are used in bicycle components, wind turbines, marine paints, sports equipment, electrical circuitry, batteries with longer lifetime, and electronics. And what are the future uses of this nanotechnology? They can be used in clothing, that is, they can be used at bulletproof clothing and semiconducting materials and spacecraft and space elevators. What this space elevators actually is, it connects from ground station to the space station, so that they can travel from ground to space. And solar panels, cancer treatments. See, actually in cancer treatments, by using chemotherapy or something else, those technologies, when we are treating these cancer cells, they may affect the other cells, but by using this nanotechnology, they can usually target the wanted cells actually. They can target the wanted cells, and they can eliminate that without eliminating other useful materials in our body. And they can also be used in touch screens, and they are used as energy storage, optics, radar, biofuel, and LCDs. Okay, coming to this nanowires. Nanowires are very thin wires. They are usually used to build tiny transistors for computer chips and other electronic devices. These nanowires are having optical, electrical, and magnetic properties. As computer is having a magnetic property, these nanowires can be used. They can store the computer data. And coming to molecular nanotechnology. Molecular nanotechnology means the study of molecules less than 0.1 nanometer or 0.1 nanometer. In this nanotechnology, we are usually having two approaches, top-down approach and bottom-up approach. What this bottom-up approach actually is? Bottom-up approach means they can, from the bottom, that is from the molecular stage, the molecules assemble to form a larger substance by molecular recognition. And coming to this top-down approach, they can start from larger entity, that is, they can start from the larger materials and will come down. And when they come down to nanoscale, the properties may differ as that of the larger scale. And coming to this applications of nanotechnology, we are having wide applications in medicine. As I have said, in medicine, we can actually induce the drugs into our body to the targeted cells or to the targeted diseases only, without affecting any other parts in our body. And electronics, food, we can use this nanotechnology in food also, for food safety, for food protection and all, and food growth. And solar cells, batteries, space, better air quality, when there are catalysts that can absorb in environment, if they can absorb the particles, By if they observe, they can actually improve the air quality and cleaner water, and without pumping and all, we can, by using these nanomaterials, it can actually clean the water, so that the countries that are facing water the countries that are facing water scarcity, they are helpful in this, and fuel cells and fuels. And coming to this nano mission, what actually our country India is doing regarding this nanotechnology. Our government has launched in 2007 nano mission. This nano mission, we have a basic research promotion, means in this nano mission, the basic research promotion means, for developing any technology, first we should have funding and technological support and infrastructure development. For studying the nanoscale ranges, we are having such a infrastructure such as a scanning tunneling microscope and all. For such a devices, infrastructure development is also needed, and nano application technological development programs have to be conducted, and human resource development, like of course we are having technology, but if we are not having any human resource to develop the technology, what the use of it? So we should inculcate the ideals of this nanotechnology, the interesting things that students should come forward to learn this nanotechnology, to develop this nanotechnology, then only we can. So human resource development is also needed, and international collaborations. Okay, these are all the things that under nano mission 2007 our government of India is planning. And what are the concerns relating to this? As we all said, it accumulates in the body, it may cause damage to brain in the fish and all. So when the nanoparticles, when the nano manufacturing materials are licensed, when they get licensed, they actually have to get first full hazard assessment is needed before giving them a license. And as these nanoparticles are very small in size, they may travel very larger distances in atmosphere, and when they react with other particles, when they we should know, we don't know how they react or how they trigger when they meet other particles. So completely this is all about nanotechnology, and the future scope of nanotechnology is very widely used. They will provide groundbreaking solutions in future. Thank you.